Hi everyone, this is Saida Fatima Mazumdar from UNC Charlotte. The corresponding and lead author of the paper are variable array and object diagrams in Java textbooks explanative. The other authors of this paper are Dr. Letulip from University of Manitoba and Dr. Perez Quinones from UNC Charlotte. So let's begin our presentation. We all know that diagrams are really powerful learning tools. According to multimedia learning theory, learners can have deeper comprehension from text with diagrams than just text alone. Diagrams have the ability to develop mental model, increase the power of recall by double, reduce comprehension error. Moreover, learner can also generate inferences and exhibit improvement in problem-solving skill if their learning material is aided with diagrams. But are all diagrams good enough to do that? Let's see. Based on the theories of mental model, Dr. Richard Mayer and Dr. Galani concluded that explanative diagrams have the ability to build learnable mental models, increase recall, and improve problem-solving skill. According to them, explanative diagrams have two major features. One is system topology and the other is the component behavior. System topology refers to the portrayal of each major component within the structure of a scientific system, and component behavior refers to the portrayal of each major state that each component can be in and the relation between a state change in one component and state changes in other components. For example, here the major component of these pump systems are the handle, piston, valves, and they are all illustrated in a system topology diagram, and how the pushing of the rod can affect the other components are portrayed in the component behavior diagram. So based on the importance of diagrams and this theory of explanative diagram, we investigated two introductory Java textbooks provide diagrams of these three fundamental introductory programming concepts: variables, arrays, and objects. And we also investigated to what extent do diagrams exhibit Mayer and others features of explanative diagrams, the system topology, and the component behavior. To answer the question of to answer the second question, we listed out the major component of variables, arrays and objects, and their state changes. Here I will present the analysis of arrays. The rest of the concept's findings can be found in the paper. So we have listed name, indices, elements, references, memory location, and the corresponding code as the major component or the system topology of arrays. The state change due to array declaration, instantiation, and assigning values were considered as the requirement for the component behavior. We sampled 15 most popular introductory Java textbooks to analyze their diagrams of primitive variables, arrays, and objects. More of our sampling techniques can be found in our paper. Here I will demonstrate how we analyze the textbook for one concept, arrays. For example, to analyze this book, let's go to the designated chapter for arrays. After going to the designated chapter, I captured the first diagram introduced there and recorded the major components. For example, here the major components are the array name, reference, indices, elements, and the corresponding code. So after that, for analyzing the component behavior, I went through the entire chapter and analyzed the later diagrams. For example, here this diagram represents the state of the array after assigning these literals. And then this diagram represents the state of the array after it has been instantiated. After collecting data from all of the 15 textbooks, we were able to answer our first question: do textbooks provide diagrams of these three fundamental programming concepts: primitive variables, arrays, and objects? We found that 12 out of the 15 textbooks graphically presented variables. 13 out of 15 textbooks provide diagrams for arrays, and 12 out of 15 textbooks provided diagrams for objects. Here are the results to answer the question: to what extent do diagrams actually exhibit mere and other features of explanative diagram, the system topology? So in our analysis, we found that 8 out of the 15 books portrayed array with name, reference, elements, indices, and the corresponding code. Along with all of this, reference was left out by 2 books. So these books represented array like this, where they portrayed the name, the elements, and the indices. Then we found out that B7 left out array name with the reference, and the diagram looks like this. They also didn't portray memory location, and they didn't provide any corresponding code. For component behavior, we can see only B11 explained declaration, instantiation, and assigning literals with diagrams. These 6 and they provide diagrams that look like this. So here is the diagram of the declaration, here is the diagram of the instantiation, and this is the diagram of assigning literals. These 6 books left out declaration and only portrayed instantiation and assigning literals. The remaining 8 books provided no diagrams to explain these state changes. B11 was the only book which provided all component behavior and almost all major components of the arrays. After the analysis, we found out that there were more visual depiction of arrays than variables and objects, though half of the books didn't provide any diagrams for state changes. We also found inconsistencies among the books while showing the system topology. For example, diagrams of some books presented reference of arrays, but others left them out. Overall, we saw almost half of the books didn't explain any state changes with diagrams for all of the 3 concepts. Moreover, the books which provided diagrams of state changes put a question mark or showed blank as a default value when the array was declared or instantiated for, for the primitive or the reference variable. This can accelerate the already existing misconception in the literature that primitive types have no default value. After analyzing all of the 15 books' diagrams, we can conclude that none of the books' diagrams possess the 2 key features, system topology and the component behavior, thus loses their opportunity in helping students build a runnable mental model of these basic concepts. Thank you for staying with me throughout the entire presentation. I would be really glad to answer your questions sent to my email address here or designated discussion board for my paper. Stay safe and stay sound.